Hello, welcome. In this episode, we want to deal with a little discussion of quadratic sequence. We've done the AP, we've done the GP. Here we are dealing with a quadratic sequence. So it is a sequence of numbers in which the second difference between any two consecutive terms is constant. So if the sequence is a quadratic sequence, then the nth term of the sequence is of this form. We can use u subscript n or t subscript n equals to an squared plus bn plus c, where the a, b, and c are just constant to be derived. Then the n is just number of terms in that sequence. So it means that if a series of sequence is given, we might not be able to apply the arithmetic progression or the geometric progression. Let's see, for example, if I have a sequence of 1, 4, 9, 16, 25, and so on. If there's a sequence in this form, we can see that the AP says that when I find the common difference of any two consecutive terms, it should be constant. So 4 minus 1 will be giving us 3. 9 minus 4 will be giving us 5. So you can see it is not the same. So we can't say common difference. The difference is there, all right, but it's not common. When it comes to GP, we'll be expecting to divide any two consecutive terms to get the same answer. So we get a common ratio. So 4 divided by 1 is 4. 9 divided by 4 is not 4. So what do? We don't have a GP. That is where the quadratic sequence comes into play. It says what? A sequence of number in which the second difference. So let's see. If I have 1, 4, 9, 16, 25. Let's find the difference. So the difference between the two, the first glance, give us 3. The difference here give us 5, right? The difference here, if I add 7, and the difference here, if I add 9. So you can see the difference is not the same. This is the first difference. Then the second difference, let's find the second difference between these terms. This will be 5 minus 3 will be 2. 7 minus 5 will be 2. Then 9 minus 7 will also be 2. So you can see that the definition says that the second difference between any two consecutive terms is constant. So the second term, if I pick the two consecutive terms, you can see I'll be arriving at what? 2, 2, 2. So that is what we are going to arrive at what? The quadratic sequence. And how do we solve it? Now, the quadratic sequence always have the difference. If you find your difference here, the common difference, how will I put it? The second common difference is always equals to this. So 2a is always equals to the common, okay, let's just say second common difference. That's it. So now if that is the case, so whatever I have is equals to 2a. That's the second common difference. So if I have 4, 4, 4, it means 2a equals to 4. So in this case, finding the a is going to be easy. The a, which is the first constant we have here. So I'll be having 2a equals to 2, which is the common difference, and that implies that a equals to 1. Do we get it? That is the first instance. So now we get this. We say that the sequence general form is in this form as a formula, right? If that's the case, then when n equals 1, don't forget the number of terms, the first term. When n equals 1, the n is the first term. And what is the first term in the sequence? 1. So n is replacing this value. So you'll be having T1 equals to AN square plus BN plus C. I believe you get the concept from here. The T1 is the Tn. Our n is 1, so we replace everywhere we see n. And don't forget, in the beginning we say our a is 1, so we replace this by 1. Then the T1 is the first term of the sequence. And what is the first term? 1. We have 1 is equals to 1 times 1 square will still be 1. Then we have b times 1 will be b plus c. In this case, when we subtract 1 from 1, we get 0, meaning b plus c is equal to 0. We take this as our first equation. So to get a second equation, in order to find the b and c, the a is already known. So we can see that when n is also equals to 2, right? If n is equals to 2, it means I'll be having t subscript 2 equals to an square plus b plus c. If you want to, you can see that always your first term is going to be a, b, c in addition, because n is going to be 1. Your second term will always be 4b plus 2b plus c. You can make that as a general term, not to be writing n equals to 2, n equals to 1. Alright. So I believe this is going to be second term from the sequence. That will be 4. So 4 equals to 2 square, 4 times a, which we know from the beginning is 1, plus 2b plus c. You can see your 4a plus 2b plus c. Just general term and you are good to go. So we know this is also going to be 4 minus this will be 0. So we're having 2b plus c equals to what? 0. Then, if that is the case, we are having this to be equation 2. Bringing the equation 1, solving the two equations simultaneously, we can subtract equation 1 from equation 2. So equation 2 minus equation 1, what happened? 2b minus b will give us only b. C minus c will be 0. So 0 minus 0 will be 0. So put b equals to 2 equals to 0 into any of the equations, 1 or 2. So let me prefer equation 2, not 1. So if it is equation 1, we can see if b is 0, then we have 0 plus c equals to 0. It implies that c also equals to 0. Therefore, the nth term is of the form, if I have Tn, that will be equals to an squared, and a is 1, so we have n squared, plus bn, and b is 0, so b times n will be 0, plus c, which is always be 0. So this becomes what we call the general term. And I believe from the beginning you knew that this is going to be a perfect square, in terms of a squares of numbers, as in 1 square, 2 square, 3 square, 4 square, 5 square, in that order. So if n here is 1, it means 1 square. If n here is 2, it means 2 square. In that regard, you can be able to generate the sequence. I believe the concept is clear. I'll give you an example to try and share your thought and your workings in the comment section for us to get interactive. So we are having this. Find the n, the next two terms, and determine an equation for the nth term of this sequence, following the same approach, the same steps, the same procedure. You arrive at your answer. Share that with us on the comment section. Bye bye.